now we'll look at some dynamics. So I've got to teach some dynamics basics first before we use Audition, just to sort of give you a bit of an example of what dynamics do. So when you look at a recording with amplitude, you've got your loudest points, which are obviously the ones that are furthest apart, and you've got your quietest points, which are the ones that are closer together. The difference between the two, the difference between the quietest and the loudest sounds, is called the dynamic range. Okay, so that's the dynamic range of the recording. On a digital recording, your dynamic range is the maximum amount of data you can capture, so the maximum number of variables from the smallest number to the biggest number. And obviously there's a maximum amount of mathematical possibilities that we can achieve on that digital recording. On an analog tape, it's the maximum saturation, the amount of iron we can actually play with on that piece of tape. To get that amplitude, and once you run out of iron, rather than distorting in the way that it does with digital and just going crackly, on a digital tape, on an analog tape, what happens is you just run out of iron and you get this really nice that iron compression where it just stops putting the sound down, and you get this really nice sort of limit effect where you just there's no more data to be had. But rather than going, I don't know what to do, like digital systems do, and just making digital noises, what it actually does is it just keeps producing the sound at the quieter level. And then there's dynamic range of a sound system. Dynamic range of a sound system is, obviously there's quietest the silence in the room, but the loudest point you can go is your maximum SPL of your sound system. So you've got a limit to how much you can push that before you get covered in cardboard. So that's kind of how you have the dynamic range of a sound system. There's also obviously the limit of your hearing, the dynamic range of your hearing, how much you can go to until it hurts. Which generally is at the point you get covered in cardboard as well. So that's kind of a dynamic range. So we can affect the dynamic range in various ways. Really interesting little device was made, probably I think it was back in the 70s, might have been even earlier actually, where you get what's called a voltage-controlled amplifier. And a voltage-controlled amplifier, as you apply a voltage to it, so it passes the signal, amplifies the signal. If you set it to a gain of 0, so it passes the signal to the degree of voltage you've applied to it. Cool thing about voltage-controlled amplifiers is you can actually turn that voltage around so that as you apply voltage to it, the volume goes down, which is a really clever little trick you can do. So if you imagine you take the volume of your signal as a voltage, because obviously all signals are voltages, as the voltage of your signal goes up, there's a few more components involved, and it's a little bit more complicated than that, but as the voltage of your signal goes up, so the amplifier turns the volume down. So you end up with what basically essentially is a self-limiting circuit. So every time the volume goes up, it turns the volume down. So you've got silence, 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 you slam the snare drum, bang, it goes off the scale too loud, but actually what happens is as the voltage increases, the voltage-controlled amplifier is pulling the volume down, so it never actually reaches the summit, and before it hits the top of the dynamic range, it's back on its way down again. Okay? Really simple little concept. So, looking at that on here, this is an analog compressor, and an analog compressor does exactly the same thing. It's got a VCA in it. Each one of these is 2 channels here, and it's got a VCA in it. So if we 2 2 2 2 2 1 2 2 2 2. Okay, so if we wind it up, open that right up, 2 2 1 2. Okay, so we've got an LED ladder here that is currently showing the input. So that's the input signal going into the compressor. It's a little bit hot, we'll turn it down, 2 2 2, like that, there we go. Okay, so we're feeding the compressor with an input signal. We've got various knobs, a threshold knob, ratio, attack, release, and an output volume. Now the output volume we don't need to worry about for a moment, but the threshold tells us at what point the compressor starts to work. So at the moment it's set to -10 decibels, so when the compressor hits -10 decibels, when the input signal hits -10 decibels, it will start to take effect. So the lower we set that control, the less the volume needs to be before that VCA starts turning the volume down. Okay? The ratio tells us how much it's going to turn down by for each decibel it goes over the threshold. Okay? So we can, if we start that, and this ladder, LED ladder here, which is all red, shows us gain reduction, which is how much we're turning the signal down by. Okay, so if we set the threshold well within where we're peaking at 0 at the moment, so if we set that to -20, so we're 20 decibels over where that's actually going to start working, and we start to crank the ratio up. So now you can see that my voice has almost dropped out of that speaker because we're turning it down by so much. So if we just back the ratio off a little, the threshold off a little bit, so I'm having a little bit less effect, and then up the ratio. So now for every decibel I go over that limit, we're going down, for every 4 decibels I go over, we're going down 1. Okay, at that ratio. So that is basically now clamping my voice, clamping my dynamic range, and not letting me go over by too much over my -20 decibel limit. Okay, so that's the basics of a compressor. There's a lot more to it than that, but the reasons we use compression, in a limiter format with a high ratio, if you're approaching the point where your digital system is going to top out, you've run out of data, and you can't, you're going to hit this digital noise. You're going too hot to tape, or too hot to track. By setting it as a limiter, it won't exceed that -20 decibel, or whatever you set the threshold for, it won't exceed that point. And that's really good for protecting your recording inputs. So if you don't quite know what your dynamic range of your show is going to be, and you're trying to record it to tape, that's a really good way of going slam. We're not going to go into digital noise, we're not going to overload the system, we're not going to clip the system, we're just going to keep it clamped at that level. So that's one use. So with a really high ratio, you can actually stop the system from overload, which means you can go hot as a tape, you can run everything into the tape harder, because you know you're safe, you're not going to go over that top end. The other way of looking at compression is actually, all you're actually doing is squeezing your dynamic range. When you squeeze it, you actually squeeze it from the bottom up rather than from the top down. So what you're actually doing is saying the difference between the loudest sound and the quietest sound is now a lot less. So if we were going to tape at 0 decibels, peaking at 0 decibels, and our quietest sound was, fractional, really, really small quiet sound, just a background hiss, and we're worried about slamming the top of that tape, the background hiss is going to be incredibly quiet relative to your highest peak at 0 dB. If we then compress that top peak down to -20, amplify the resulting sound by 20 decibels, back up, so we're now, our peak is still at the top point, still at peaking at 0 dB, but our hiss, our quietest sound, is now 20 decibels louder. You see what we've done? So we brought it from the bottom up. So what you can actually do is to bring your quietest sounds out of the mix and not make your louder sounds any louder. And that can be really handy for things like the proximity effect, where you've got some people on stage at the front right next to the microphone, and some people at the back of the stage where their sound's going to be a lot thinner, a lot further away, a lot quieter. So by compressing the entire mix, we can actually bring, although we're technically turning the people down at the front of the stage, what we're actually doing is amplifying the people at the back. If we use the makeup gain to bring the whole thing back up in level, we're actually bringing those people at the back of the stage forwards relative to those at the back.